సో ఏ రసాయన చర్యలలో చర్య రేటు క్రియాజనక గాఢత పదాల ఘాతాంకాల మొత్తము 3కు సమానం అవుతుందో అలాంటి చర్యలను ఏమంటాము? థర్డ్ ఆర్డర్ రియాక్షన్స్, తృతీయ క్రమాంక చర్యలని అంటాం. తృతీయ క్రమాంక చర్యలు అని అంటాం. సో look here my dear friends, A2 forms P. So there is no condition that it should be 3. It may be 3 or it may not be 3. It may be 2, it may not be 2, because we told yesterday. What did we say here? Always the order of the reaction is determined with the help of experimental results only, that's all. So therefore, here the rate of reaction is equal to rate constant into a to the power 3. Such type of reactions are called as third order reactions. For third order reactions, the integral rate constant is given by K is equals to what? 1 by 2T into 1 by A minus X whole square minus 1 by A square. 1 by 2T into 1 by A minus X whole square minus 1 by A square. So this is the integral rate constant for the third order reactions. And what are the units of rate constant? So the units of rate constant of third order is mole inverse to liter square second inverse. And half-life. Half-life period is given by 3 by 2 Ka square. 3 by 2 Ka square. These are the important points should be noted regarding this third order reactions. And if we see the examples, 2NO, this O2 gives rise to 2NO2. And Cl2 plus O2 gives rise to 2ClO2. These are some of the examples of third order reactions. Here, as we know that generally the third order reactions are less because the number of colliding molecules, the probability of the collisions between the 3 molecules is less than that of 2. That's why generally we have less reactions which are pertaining or which are following third order kinetics. And now, my dear friends, I want to say one simple relation between all these. I want to give the form of table. Here, order of the reactions. Here, expression for rate constant K. And units of K. Half-life period. Half-life period. Here, zero order if you take. Zero order means what is the rate constant? K is equals to X by T. This can also be written as R naught minus R by. What are the units? Moles per liter per second. And what is half-life? T of is equals to what here? A by 2k. A by 2k. This is related to zero-order reactions. That is rate constant, units of. And if you take first order reactions, so K is given by 2.303 by T log A by A minus X. Here, what are the units of this one? Simply second inverse. And what is half-life period? T of is equals to 0.693 by K. And here this can also be written as 2.303 by T log or not by. This is about the first order reactions. And if you see the second order reactions, K is equals to 1 by T into 1 by A minus X minus 1 by A. 1 by A minus X minus 1 by A. Here, what are the units here? Moles, inverse, liter, second inverse. Here, what is T of? T of is equals to 1 by Ka. 1 by Ka. This is about the second order reactions. None of the screenshot this one is going to try. This is a highly useful for you. So you take this. This is zero order, first order, second order, and 1 second. Is it visible, my dear friends? Is it clear, all of you, my dear friends?
Sir, clear, sir, clear.
Okay, thank you, Ashok sir. Thanks, sir. Now, coming to third order reactions, K is given by here, third order, K is given by 1 by 2p into 1 by A minus X minus 1 by. Right. This is about, and what are the units here? Mole inverse to liter square seconds. And what is the half-life? We can see now. What is half-life? T of is equal to 3 by 2 K is 3 by 2 K is. This is about the order. And if you see about the nth order, here K is given by 1 by N minus 1p into 1 by A minus X to the power N minus 1 minus 1 by A to the power N minus And what are the units here? Mole 1 minus n liters n minus 1 units. And for this one, we have T of is inversely proportional to A to the power of n minus 1. T of is inversely proportional to A to the power of n minus 1. And here the condition is for this one is always n should be greater than or equal to 2. For the reactions, if n is greater than or equal to 2, then this principle is applied. This formula is applied. So, Nana, if you remember this table, definitely we are able to do one problem because we can able to answer the units. We are able to do the half-life. But this one. So, Nana, you please remember this one. This is very, very important and useful table in this one. And here, my dear friends, here right. Here, my dear friends, here, look here. What are the units? Mole 1 minus n liters n minus 1 units. So, for example, if you take n is equal to 0, that is 0 order reaction, this becomes what? Mole 1 minus 0, mole. Liter n minus 1, minus 1. For first order reactions, mole 1 minus 1, 0. Liters 1 minus 1, 0. So anything to the power of 0 is equal to 1. So for n is equal to 1, we have the units of s minus 1. That's all. Because we know like this. Mole 1 minus 1, liter 1 minus 1, second inverse. This becomes what? 0. This becomes what? 0. Anything to the power of 0 becomes 1. So therefore, the units of first order is the units of second. And if n is equal to 2, so what we write? Mole 1 minus 2 becomes minus 1. And liter n minus 1, 2 minus 1 is what? Liter. Second inverse. And if n is equal to 3, mole 1 minus 3, mole inverse 2. Liter 3 minus 1, liter square, s minus 1. Like this, if you remember these units for nth order, you should be able to write the units of any type of reactions of either 0 order or first or second or third order reactions. Now, we are entering a new word, that is molecular chemistry. Here, this is another important aspect of chemical kinetics, that is molecularity. Cherya anta. Cherya anuta. Cherya anuta. లేదా చర్య అనుకతలు అంటారు. బుక్ లో అనుకత ఉంటుంది లేదా అనుత. హరికథ కాదు మై డియర్ ఫ్రెండ్స్, అనుత. Here generally, if a reaction proceeds in more than one step, among those steps, only one of the steps proceeds in a slow manner. All the other steps proceed fastly. So the step which proceeds slowly is called as rate determining step, or RDST, or elementary step of the reaction. ఒక రసాయన చర్య ఒకటి కంటే ఎక్కువ దశల్లో జరిగినప్పుడు ఏదో ఒక దశ మాత్రమే నెమ్మదిగా జరుగుతుంది. ఆ నెమ్మదిగా జరిగే దశను రేటు నిర్ధారక దశ లేదా ప్రాథమిక దశ అని అంటాం. దెన్ వాట్ ఈస్ మాలిక్యులారిటీ? చర్య అణుత అంటే ఏంటంటే the number of molecules which participate in the rate determining step or elementary step of a reaction is called as molecularity of the reaction. The number of molecules or atoms or ions which participate in the rate determining step or elementary step of a reaction is called as molecularity of the reaction. ఒక రసాయన చర్య యొక్క రేటు నిర్ధారక దశలో పాల్గొనే అణువుల సంఖ్య లేదా పరమాణువుల సంఖ్య లేదా అయాన్ల సంఖ్యని చర్య అణుత అని అంటాం. ఒక రసాయన చర్య ఒకటి కంటే ఎక్కువ దశలో జరిగినప్పుడు నెమ్మదిగా జరిగే దశను రేటు నిర్ధారక దశ లేదా ప్రాథమిక దశ అని అంటాం. ఈ విధంగా ఒక రసాయన చర్య యొక్క రేటు నిర్ధారక దశలో పాల్గొనే అణువుల సంఖ్య లేదా పరమాణువుల సంఖ్య లేదా అయాన్ల సంఖ్యని అణుత అని అంటాం. సో ఆల్వేస్ ద మాలిక్యులారిటీ ఈస్ ఈక్వల్ టు either 1 or 2 or 3 only. Here the molecularity is always either 1 or 2 or 3. It is not equal to 0 and it is not equal to fraction. This is a very important aspect regarding molecular reaction. Here, always the molecularity is determined by what? Reaction mechanisms. Reaction mechanisms, and always this is pertaining to the molecule of the reaction is pertaining to what? Only simple reactions. So always this is dependent on only what? Rate determining step. So rate నిర్ధారక దశ నుంచి మాత్రం పర్ఫెక్ట్ అని చెప్పవచ్చు. And if we know this is determined critically by reaction mechanism only, that's all. అంటే చర్య క్రియా విధానం నుండి మాత్రమే మనము చర్య అణుతను నిర్ణయిస్తాము. అదే ఆర్డర్ ఆఫ్ ద రియాక్షన్ తీసుకున్నట్లయితే ఆర్డర్ ఏంటి? ఆర్డర్ if you see the difference between order of the reaction and this one. Order. Here, if you see the order of the reaction, this may be equal to 1 or 2 or 3 or 0 or fraction. ఇది శూన్యము కావచ్చు, 1 కావచ్చు, 2 కావచ్చు, 3 కావచ్చు, లేదా భిన్నం కూడా ఉండవచ్చు. But here molecularity must be equal to either first that means unimolecular reactions or bimolecular or termomolecular reactions. And second one, order of the reaction, చర్య క్రమాంకం ఎప్పుడైనా కూడా ప్రయోగ ఫలితాల ఆధారంగా మాత్రమే నిర్ణయిస్తాము. The order of the reaction is determined with the help of experimental results only, whereas the molecular of the reaction is determined with the reaction mechanisms. చర్య క్రియా విధానం అనుసరించి సైద్ధాంతికంగా థియరిటికల్ గా చర్య అణుతను నిర్ణయిస్తాం. And here the order of the reaction is pertaining to either complex reactions or simple reactions. So complex reactions means what? The reactions which do not complete in one step. అంటే ఒకే దశల్లో జరగకుండా అనేక దశల్లో జరిగే చర్యలు మనం ఏమంటామంటే కాంప్లెక్స్ చర్యలని అంటాం. Right? This is about the order and molecule of the reaction. And important collision theory, అభిఘాత సిద్ధాంతం. collision theory of reaction states. Collision theory of reaction states. చెరియ రేటుల అభిఘాత సిద్ధాంతం. Here, my dear friends, we know very well, always the reactant molecules collide with each other to form products. క్రియాజనక అణువుల మధ్య అభిఘాతాల వలన క్రియాజన్యాలు ఏర్పడతాయి. ఒక రసాయన చర్య జరగాలంటే కండిషన్ ఏంటి? అకార్డింగ్ టు దిస్ థియరీ, there must be collisions between the reactant molecules should take place. But not all the collisions will give products. అన్ని అణువుల యొక్క అభిఘాతాలు క్రియాజన్యాలను ఏర్పరచవు. Not all the collisions will give the products. Only some of the collisions will give the products. Those collisions are called as fruitful collisions or effective collisions. కొన్ని అణువుల మధ్య అభిఘాతాల వలన మాత్రమే క్రియాజన్యాలు ఏర్పడతాయి. ఆ అభిఘాతాలను ఏమంటామంటే ఆ తాడనాలను ఉంటాం, అభిఘాతాలను తాడనాలను ఉంటాం. సో ఈ తాడనాలను ఏమంటామంటే ఫ్రూట్ఫుల్ కొలిజన్స్, ఎఫెక్టివ్ కొలిజన్స్, ప్రాభావిక అభిఘాతాలు లేదా ఫలప్రదమైన అభిఘాతాలని అంటాం. Then what type of collisions will give the products? Only the collisions between the molecules which have some optimum energy are capable of giving products. Only the collisions between the molecules which have some optimum energy will give the products. కేవలం కొంత శక్తి లేదా తగినంత శక్తి గల అణువుల మధ్య అభిఘాతాల వలన మాత్రమే మనకు క్రియాజన్యాలు ఏర్పడతాయి. That those molecules are called as actuated molecules. Now we can explain this with the figure. This is energy, shakti. This is reaction path, reaction coordinate. Reaction path or reaction coordinate. So let us say ఇది క్రియాజనక అణువులం యొక్క శక్తి, the energy of reactants. This is the energy of bonds. Here, this energy, this is called as threshold energy. ప్రారంభ శక్తి లేదా ఆరంభ శక్తి అని అంటాం. threshold energy, ప్రారంభ శక్తి లేదా ఆరంభ శక్తి. మనం ఇందాక చెప్పుకున్నాం, అన్ని అణువుల యొక్క తాడనాలు క్రియాజన్యాలను ఏర్పరచవు. కేవలం కొన్ని అణువులు. ఏ అణువులు? తగినంత శక్తి గల అణువులు. అనగా ఆ తగినంత శక్తి ఎంత? ప్రారంభ శక్తి, threshold energy. Now we can say that the molecules which possess the energy which is equal to threshold energy or more than that are capable of giving products. ఏవైతే అణువులు ప్రారంభ శక్తి లేదా ఆరంభ శక్తికి సమానమైన శక్తిని కలిగి ఉన్నాయో లేదా అంతకన్నా ఎక్కువ శక్తిని కలిగి ఉన్నాయో వాటి అభిఘాతాల వలన మాత్రమే మనకు క్రియాజన్యాలు వస్తాయి. This is about what collision theory. And here always the number of collisions taking place per unit time in unit volume is called as what? Collision frequency. ప్రమాణ కాలంలో ప్రమాణ ఘన పరిమాణంలో ఉండే క్రియాజనక అణువుల మధ్య జరిగే అభిఘాతాల సంఖ్యను పౌనపున్యము అని అంటాం. కొలిజన్ ఫ్రీక్వెన్సీ అభిఘాతాల పౌనపున్యం. సో వీటన్నిటిని క్రోడీకరించి ద సైంటిస్ట్ ప్రపోజ్ వన్ ఈక్వేషన్ K is equals to A into e to the power of minus EA by RT, where K is rate constant, A is what is a constant frequency factor, Paunapunya Gunakam antam. So what is EA? EA means energy of activation, Uttejita Shakti. R is universal gas constant, E is absolute temperature. And what is put together? E to the power of minus EA by RT. What is this? This is the fraction of the molecules which have the energy which is equivalent to threshold energy or more than that. That means the fraction of molecules which possess the energy which is equivalent to threshold energy or more than that. And what is this energy of activation? Now we can see. Now we can see that. Here, this is. This is the energy. This is reaction coordinates. Here, this is the energy, average energy possessed by the reactant molecules. This is the average energy possessed by the products. And this is energy, that is threshold energy. Threshold energy. Here, the difference between the threshold energy and average energy possessed by the reactants is called as energy of activation of reactants. ఆరంభ శక్తి మరియు క్రియాజనక అణువుల సగటు శక్తికి మధ్య గల భేదాన్ని ఉత్తేజిత శక్తి అని అంటాం. So the difference between the threshold energy and energy possessed by the molecules is called as energy of activation of products. అంటే products కలిగి ఉన్నటువంటి క్రియాజన్యాల యొక్క సగటు శక్తికి మరియు threshold ఎనర్జీకి మధ్య గల భేదాన్ని మనం ఏమంటామంటే products యొక్క క్రియాజన్యాల యొక్క ఉత్తేజిత శక్తి అని అంటాం. And here, according to this theory, the collision should take place and also in proper direction. So when the collisions takes place between the molecules, that is reactant molecules, in proper direction, only give the products. So the collisions between the reactant molecules in improper direction cannot give the products. So that is given by one more, what, A into e to the power of minus A by RT. And one more factor is added, that is rho, that is called steric factor should be added for that equation. So, but generally this is considered. But the Arrhenius equation is not only this one, A into e to the power of minus A by RT. This is the Arrhenius equation. If we add that one, that includes steric factor. So this is about the collision theory of reaction rates. Cheriya abhigatala. What? Cheriya ratula abhigata siddhantam. And here, my dear friends, by watching this figure, this is energy diagram for what type of reactions? Exothermic reactions or endothermic reactions? Exothermic reactions or endothermic reactions? Ushna mochaka charyala, ushna grahaka charyala. Here, always by observing this one, the energy of products is less than that of reactants. So therefore, this is an example of exothermic reactions or exoergic reactions. The reactions where the energy of products is less than that of reactants are called as exothermic reactions or exothermic reactions. ఏవైతే రసాయన చర్యలలో క్రియాజన్యాల యొక్క శక్తి క్రియాజనకాల శక్తి కంటే తక్కువగా ఉంటుందో వాటిని ఉష్ణ మోచక చర్యలు అంటాం. అనగా ఆ చర్యలో ఉష్ణం విడుదలవుతుంది. The reactions in which heat energy is evolved are called as exothermic reactions. Always, my dear friends, in exothermic reactions, delta H is always negative. And delta E or delta U is always negative. Why? Because if we have A to form products, the product should have less energy, then only the amount of energy is released. That's why delta H means what? H2 minus H1. This is initial state. This is final state. So delta H must be what? Delta H is equal to H2 minus H1. So always H2 should be less than H1. Means what here? The product should have less energy than that of reactants. What is H? Enthalpy. What is enthalpy? Total heat content of the system at constant pressure is called as enthalpy. That you can read perfectly in the thermodynamics. What is E? Internal energy, ERU. That is what? The energy possessed by the molecules internally, which includes potential energy, kinetic energy, translation energy, vibrational energy, rotational energy, like that. That we can see in detail in thermodynamics. So by figure, they will give a figure and ask us, this figure indicates what type of reaction. That is always, this is what? Exothermic reaction. ఉష్ణ మోచక చర్య. మరి ఉష్ణగ్రాహక చర్య ఎలా ఉంటుంది చూద్దాం. ఉష్ణగ్రాహక చర్యలలో this is energy, this is reaction coordinates. Always the products have more energy than the reactants. This is the energy of products, this is the energy of reactants. Here, what? The products have more energy than that of this one. And always for endothermic reactions, ఉష్ణగ్రాహక చర్యలు అంటే ఏవైతే చర్యల్లో ఉష్ణం గ్రహించబడుతుందో అట్టి చర్యలను ఉష్ణగ్రాహక చర్యలు అంటాం. లేదా the reactions in which heat energy is required are called as endothermic reactions or endoergic reactions. So always in this one, delta H is and delta E or delta U is positive. Delta E or delta H is positive. So this is about what? Endothermic reactions, exothermic reactions. This is about collision theory. And now we can see the factors which affect the rate of reaction. Factors affecting rate of reactions. Here, some of the factors like nature of reactions, Second one, what is next one? The concentration of reactants. Third one, effect of temperature. Fourth one, effect of catalyst. Effect of temperature, effect of a catalyst. Here we see the reactions between ionic compounds are very fast. The reactions between ionic compounds are very fast. For example, if you take NaNO3, 1 second. Sodium chloride plus silver nitrate will give us AgCl plus NaNO3. So here this reaction is completed within fraction of seconds. Within fraction of second. That's all. Why? Because it is very fast reaction. And the reactions between covalent compounds are slow. Now we can see H2 plus I2 will give us 2HL. So how does it reaction process? Now we can see here this one H. సమయోజనీయ పదార్థాలలో చర్యలు నెమ్మదిగా జరుగుతాయి. సమయోజనీయ పదార్థాల మధ్య చర్యలు నెమ్మదిగా జరుగుతాయి. ఎందుకు? కొత్త బంధాలు ఏర్పడడానికి ముందు పాత బంధాలు విడిపోవాలి. సో పాత బంధాలు విడిపోయి కొత్త బంధాలు ఏర్పడడానికి కొంత టైం పడుతుంది, కొంత కాలం పడుతుంది. కాబట్టి the reactions between covalent compounds are slow when compared to that of ionic compounds. So to make the old bonds, to break the old bonds and to make the new bonds, some time is required in the case of covalent compounds. And hence the reactions between the covalent compounds proceeded slowly than that of ionic compounds. In the ionic compounds, there won't be breaking and making the new bonds or breaking old bonds. Why? Because only the electrostatic attraction forces takes place. Electrostatic attraction force takes place between the ionic compounds, opposite charged ions, and hence they proceed fastly, they proceed slowly. Next one, concentration of reactants. We studied yesterday's class. The rate of reaction directly proportional to the product of molar concentrations of reactants according to law of mass action. ద్రవ్యరాశి క్రియానియమం ఆధారంగా మనం ఏం చెప్పవచ్చు? చర్య రేటు, చర్యలో పాల్గొనే క్రియాజనక అణువుల యొక్క మోలార్ గాఢతల లబ్ధానికి అనులోమానుపాతంలో ఉంటుంది. So therefore, గాఢత పెరిగినట్లయితే చర్య రేటు పెరుగుతుంది, గాఢత తగ్గినట్లయితే చర్య రేటు తగ్గుతుంది. నెక్స్ట్ టెంపరేచర్. If you see this temperature, what do we get? By increasing the temperature, the rate of reaction increases. By increasing the temperature, the rate of reaction increases. Why? Because by increasing the temperature, the collisions between the molecules taking place per unit time, per unit volume increases. That means the collision frequency increases by increasing the temperature. It is observed that in many examples that by increasing the temperature by 10 degrees centigrade, the rate of reaction increases by 2 times. So for example, K25 plus 10 divided by K25 is equals to approximately equal to 2 or greater than 2 in the case of some cases. And to know about the effect of temperature, according to Arrhenius equation, K is equal to A into e to the power of minus A by RT. K is equal to A into the power of minus RT. At a particular temperature, it's T1, this is written as K is equal to A into e to the power of minus A by T1. K1. At T2, K2 becomes A into e to the power of minus EA by RT2. So by getting all these things, we can get one equation. What is the term? We can see here. This we can write log. So ln K1 is equals to ln A minus EA by RT1. Similarly, ln K2 is equals to ln A minus EA by RT2. Here, ln K2 minus ln K1 is equals to, what is ln A by x? Ln x is equal to log to the x to the base. This is ln x. So this is given by ln A minus what? EA by RT2 minus of ln A minus EA by RT1. So this becomes what? Ln K2 by K1, because log A by B is equal to log A minus log B. This is given by ln A minus EA by R common here, once A by RT2 minus ln A minus of minus plus EA RT1. So ln A cancels. So ln K2 by K1 is equals to EA by RT1 minus EA by RT2. So here we can write ln K2 by K1 is equals to EA by R common and 1 by T1 minus 1 by T. And this is ln. If we remove this one, log. So always ln x is equal to ln x is equal to 2.303 log x. This is the principle. Log means that is to the base 10. So here this becomes 2.303 r. This goes to numerator, denominator here, because this is 2.303 log. This comes to the denominator. So with this one, we have some problems in the entrance, and in the coming classes we can see the problems on all these topics. Don't worry, we are here. Don't fear. Definitely we can solve no number of problems in this chapter. First we can get a brief summary of this one. Later we can go into that one. So here, this is from this we have problems. So log K2 by K1 is equal to EA by 2.03 R 1 by T1 minus 1 by T2. So this can also be written as log K2 by K1 is equal to EA by 2.303 R into T2 minus T1 by T1. Okay. Now this is like y is equal to mx. Now if we plot log K2 by K1, this is T2 minus T1 by T1 T2 if we take on the y-axis. So we can get a straight line where the slope will become what? 2.3 EA by 2.303 R. So by knowing the K1 value, K2 value, and T1 value, T2 value, we should be able to know the energy of activation. So this is about the effect of temperature, my dear friends. So by increasing the temperature, the rate of reaction increases by 2 times. Okay, this is the effect of temperature. And the next one is effect of catalyst. So what is catalyst? First we should know. Prerakam. catalyst. ఒక రసాయన చర్యలో వినియోగింపబడకుండా చర్య యొక్క రేటును పెంచే పదార్థాన్ని ఉత్ప్రేరకం అని అంటాం. The substance which is added to the reaction mixture but which do not participate in the reaction, only it improves or increases the rate of reaction, is called as catalyst. Then why the reaction increases? By using the catalyst. Now we can see. Just now we have seen the graph of what energy versus reaction coordinate to know about the what collision theory. Here, let us say this is the reactants, energy of the reactants, this is the products, this is what threshold energy. Here, the difference between the average energy possessed by the reactants and threshold energy is called as what? Energy of activation. So, క్రియాజనక అణువుల యొక్క సగటు శక్తి మరియు ఆరంభ శక్తుల మధ్య భేదాన్ని ఉత్తేజిత శక్తి అని అంటాం. మరి క్రియాజనక యొక్క శక్తిని మనం తగ్గిస్తాం ఎలా? సో ఉత్తేజిత శక్తిని తగ్గించడం వలన చర్య రేటు పెరుగుతుంది. Now we can see the reaction proceeds by this manner in presence of here this is the absence of catalyst. This is in the presence of catalyst. So now see, my dear friends, here for example, let us assume that this is 20 kilocalories. Let us say this is 40 kilocalories. Let us say this is the 60 kilocalories, and so on. This is the 80 kilocalories, and so on. This is 5 minutes, 10 minutes, 20 minutes, like that. Here, the possession of this much energy, that means the number of molecules possess this much of energy is less when compared to the molecules which have this much energy. Look here, my dear friends, just by watching this, let us say, by watching this graph, for example, so no issue. So if we observe, just for easy understanding, I am telling my dear friends, this is not accurate, but just to the understanding. So, okay, రసాయన చర్య తీసుకున్నట్లయితే 68 క్యాలరీస్ ఉన్నటువంటి అణువుల సంఖ్యతో పోల్చితే 40 క్యాలరీస్ ఉన్న సంఖ్య ఎక్కువగా ఉంటుంది. So, for example, in our classroom, the number of students who have distinction is less when compared to the number of students who have second class. So, second class means the students which have 50% marks. Distinction means who have some 75% marks. So, the number of students who have 50% is more than that of 75%. So, therefore, the rate of reaction is more in the presence of catalyst. Why? Because it is decreasing the activation energy. ఉత్ప్రేరక సమక్షంలో ఏం జరుగుతుంది? ఉత్ప్రేరక సమక్షంలో ఏం జరుగుతుంది? ఉత్తేజిత శక్తి విలువ తగ్గుతుంది. Then automatically the rate of reaction increases. So these are some of the factors which influence the rate of reaction. Now, my dear friends, you can see some other topic. You see some problems here in that one. If a reaction follows first order kinetics, The rate constant of a reaction is the rate constant of the reaction is 0.0693 second inverse. What is its half-life? The rate constant of a reaction is 0.0693 second inverse. What is its half-life? ఒక రసాయన చర్య యొక్క రేటు స్థిరాంకము 0.0693 సెకండ్ ఇన్వర్స్ అయిన ఆ చర్య అర్ధాయువు ఎంత? మరి ఇది జీరో ఆర్డరా, ఫస్ట్ ఆర్డరా, సెకండ్ ఆర్డరా, థర్డ్ ఆర్డరా మనకు తెలియదు. హౌ డు వి నో? Just by watching the units. So the units are given as second inverse. Means what? It is first order. But the first order half-life is equal to what? 0.95. So look here, my dear friends. Divided by 0.0693. సో నన్ను చాలా మంది చేసే పొరపాటు ఇక్కడ ఒక చిన్న 2-3 సెకండ్స్ టైం ఎక్కువ పడుతుంది, బట్ వీ కెన్ గెట్ అక్యురేట్ ఆన్సర్. సో దీన్ని ఏం చేయాలంటే మీరు దయచేసి మీరు ప్రాక్టీస్ చేయండి. ఐ ప్రాక్టీస్ అండ్ యూ ప్రాక్టీస్, బికాస్ ఇట్ గివ్స్ అస్ కరెక్ట్ ఆన్సర్. ఆ కన్ఫ్యూజన్ లో మనం రాంగ్ ఆన్సర్, మన కాన్సెప్ట్ తెలుసు మనం చేస్తాం, కానీ రాంగ్ ఆన్సర్ పెట్టడానికి అవకాశం ఉంది. ఎంట్రన్స్ లో మన కాన్సెప్ట్ ఉంటుంది, బట్ ఆ కన్ఫ్యూజన్ లో మనం రాంగ్ ఆన్సర్ పెట్టాం. నో వే, వీ హ్యావ్ టు గివ్ కరెక్ట్ ఆన్సర్. దట్స్ ఆల్. ద స్టూడెంట్స్ ఆఫ్ KGC coaching students do not commit mistakes in entrance exams. So that is what I can say, like 693 by 1000, 10,000 by 690. So what? 10. What is this? Seconds. Are you followed, my dear friends? Just it takes 1 or 2 or 3 or 4 seconds more time, but we can get correct answer. So please practice in this style to get the correct answers. Okay, options is third, evo is third, on a correct answer. For example, answer options is third, 1 is equal to 100, 200, 400, 10. 1 second. 10 seconds. So our answer is 10 seconds. So for example, మన ఆన్సర్ ఇక్కడే ఉందనుకోండి, డోంట్ సీ దిస్, దట్స్ ఆల్. సో ఇక్కడ కన్ఫ్యూజ్ చేస్తాడు. ఇంకొకసారి ఏమంటాడంటే ఫస్ట్ ఆన్సర్ 10 minutes అంటాడు, సెకండ్ ఆన్సర్ 10 seconds అంటాడు, థర్డ్ ఆన్సర్ 10 hours అంటాడు, 10 months అంటాడు. ఇలా కూడా కన్ఫ్యూజ్ చేస్తుంది. ఇక్కడ మనకి ఇక్కడ వచ్చింది 10 వచ్చింది, థర్టీ మనం ఏం చేస్తాం, 10 minutes అని పెట్టేసాం, బస్ 10 కనపడ్డా, చలో देखो 1 is correct answer बोल के हम इसको लगाते. So please be careful, my dear friends. Be cautious while writing the entrance exams. మనం చెప్పినవన్నీ యాక్చువల్ కాంపిటీషన్ between only 5%. That's all. మనం ఆ 5% లో ఉండాలి. So like this, you can see the problem. And next problem. The half-life period of a first order reaction is 8 minutes. The half-life of a first order reaction is how much? 8 minutes. How much time does it take to complete 75% of the reaction? The half-life period of a first order reaction is 8 minutes. How much time does it take to complete 75% of the reaction? ఒక ప్రథమ క్రమాంక చర్య అర్ధాయువు 8 నిమిషాలు అయినా ఆ చర్య 75% పూర్తి కావడానికి పట్టే కాలం ఎంత? So very simple, my dear friends, please remember, in the case of first order reactions, T75% is equals to 2 into TR. That's all. This is not possible all other 0 or second like that. T75 is equal to what? 2 into TR. So this is equal to what? 2 into 8. This is equal to what? 16 minutes. 16 seconds entered. 16 minutes entered. 3. 1.6 seconds. 4. 160 minutes. So my dear friends, 16 minutes. చాలా కేర్ఫుల్ గా ఉండాలి, ఎందుకంటే హాఫ్ సెకండ్ ఇచ్చాడు, మనకి మినిట్స్ లో ఇచ్చాడు. So therefore we should be very cautious. So what is our option? Second one is our option. To the reaction. By increasing the concentration of a reactant by 2 times, the rate of reaction is increased by 2 times. But the rate of reaction is by 4 times. 4 times by increasing the concentration by 2 times. Then what is the order of the reaction? What is the order of the reaction? క్రియాజనకాల గాఢతను రెట్టింపు చేసినప్పుడు చర్య రేటు 4 రెట్లు పెరిగినది అయినా ఆ చర్య క్రమాంకము ఎంత? ఆప్షన్స్ 0, ఫస్ట్, సెకండ్, థర్డ్ ఆర్డర్ రియాక్షన్స్. So very simple here, Nana. Rate is proportional to concentration over M. మనం చెప్పుకున్నాం కదా. So dx by dt is proportional to what? Concentration. Very simple one. Rate is proportional to C to the power of n. So here what can we say here? Simply R1 by R2 is equals to R1 by R2 is equals to C1 by C2 to the power n. Or this can also be written as R2 by R1 is equal to C2 by C1 to the power n. So now with this one, R2 by R1. So what we told here, the rate of reaction is by 4 times. So R2 by R1 is how much? 4. By C2 by C1 is how much? So from this, I can say like this. Let us say R2 is equal to 4R1 and C2 is equal to 2C1. Well, because the concentration is increased by 2 times. The rate of reaction is by 4 times. So R2 becomes 4R1, C2 is equal to 2C1. You substitute here. 4R1 by R1 is C2. How much? 2C1 by C1 will power R1 cancel, C1 cancel. So 4 is equal to 2 to the power of n. So 2 square is equal to 2 to the power of n. Therefore, it is equal to. Therefore, the order of the reaction is 2. So this is. What is the option? E2 locally, My dear friends. So like this, we can see the problems in this one. Are you followed? Students, we can stop here. We can see in the next class. Thank you, my dear friends. I have another class, and hence we can stop here, my dear friends. Thank you for your cooperation. You can see some of the topics in the next class. Is it useful, my dear friends? Dr. Ashok Garu. Dr. Ramesh Garu. Okay, see you children. Bye. I can stop here.